Today we'll learn about theoretical and experimental probability. Let's say you had a fair die and a trick die and wanted to figure out the probability of rolling a 5 on each. Well, we already know how to find the probability for the fair die. That's the number of desired outcomes over the total number of possible outcomes. So here, that is 1/6, since there is one desired outcome, rolling a 5, and 6 possible outcomes. But what about the trick die? Since it's not a fair die, we don't know how to calculate the probability. But we can use experimental probability to help us here. Experimental probability is based on the results of an experiment where you test probability. It's given by the number of times an event occurs out of the total number of trials. So for our trick die, let's say we roll it 10 times and get these results. So we rolled a 5 3 out of 10 times. That means the experimental probability is 3/10, and we can use that to find the probability of our next roll being a 5. Great. Now let's practice finding experimental and theoretical probability with some examples. At Downtown Dogs, 10 of the last 15 customers wanted mustard on their hot dogs. What is the experimental probability that the next customer will want mustard? Remember, experimental probability is the number of times an event occurs out of the total number of trials. So here we want the number of customers who wanted mustard over the total number of customers, which is 10 over 15. This can be simplified to 2/3. So the experimental probability that the next customer will want mustard is 2/3. Let's try another one. You spin a spinner. We want to find the probability of not spinning 3. This is asking for the theoretical probability, so we need the number of desired outcomes over the total number of outcomes. Well, there are 3 ways to not spin a 3, by spinning a 1, 2, or 4. So there are 3 desired outcomes over 4 total outcomes. So our chance of spinning not a 3 is 3/4, which is 75%. We can actually do this problem another way. Since we can only spin a 3 or not spin a 3, the probabilities of those options must add to 1. So we can subtract the probability of spinning a 3 from 1 to get the probability of not spinning a 3. Well, we know there is only one desired outcome, spinning a 3, so this probability is 1/4, and 1 minus 1/4 is 3/4, so we again get 75%. In both approaches, the probability of not spinning a 3 is 75%. Great, let's do another experimental probability example. Judy surveyed some students at her school about their favorite primary color. What is the experimental probability that the next student Judy talks to will pick red? The experimental probability here will be the number of students who picked red out of the total number of students surveyed. 2 students picked red, but how do we find how many were surveyed? Well, we add 3 plus 2 plus 5 to get a total of 10 students surveyed. The probability is 2/10, which simplifies to 1/5. So the experimental probability that the next student Judy talks to will pick red is 1/5. Let's do one more example on experimental probability. You pick a card at random. What is the probability that the card is even or a divisor of 18? So first, we need to find how many ways there are to draw an even number. Well, you can draw a 6 or 8, so there are 2 ways. Now, how many ways are there to draw a divisor of 18? You could draw a 6 or a 9, so there are also 2 ways. Great. So how many favorable outcomes do we have in total? We have 3, namely drawing a 6, 8, or 9. So there are 3 desired outcomes over the 5 total cards, which means our probability is 3/5, or 60%. Thanks for watching.